In the last class, we come across about the equation of normal to the circle S is equal to 0 at the point x1, y1 as x minus x1. This is the circle at this point. This is a tangent. This is the normal. Normal always passes through the center of the circle. This is a point P of x1, y1. The equation of normal at P of x1, y1 is x minus x1 by x1 plus j is equal to y minus y1 by y1 plus f. This is the equation of normal we come across it earlier. Today we shall discuss about the nature of a line and a circle. Let y is equal to mx plus c be the line. You call it as 1, and x square plus y square is equal to r square be the circle. Now from 1 and 2, come on, either convert quadratic in x or quadratic in y. So therefore what I do is x square plus mx plus c whole square is equal to r square. Now you expand this. This is nothing but x square, m square, x square, c square. This is 2mxc is equal to r square. Okay. Now this becomes 1 plus m square into x square, that is 2mc into x plus c square minus r square is equal to 0. You call this equation as 3, right? Equation 3 is a quadratic in x. To decide the nature of the roots, let us find out its discriminant. Depends upon the discriminant, we can argue what type of roots it has. So therefore delta is equal to b square minus 4ac, right? Now this is nothing but ax square plus bx plus c. Now this becomes 4m square c square minus 4 into 1 plus m square into c square minus r square is equal to 0. So therefore this is nothing but you can take out 4m square. Now 4 is taken outside, that is m square c square, that is 1 into this c square minus of minus plus r square. Next mc square, next minus of, that is m square c square, that is m square c square, then m square r square. Now this m square c square, this and this get cancels. Therefore we are left with here r square, here r square. You can take out common factor. Therefore 1 plus m square into r square minus c square, right? Minus c square. This is called discriminant. Now case 1. What is case 1? I am going to do is case 1. Yes, when the line 1 cuts the circle 2, that is like this, means the line meets in two distinct points. This is the radius of a circle, right? Now this is the what? Center. So therefore you can very well observe, when the line cuts a circle in 2 points, it's a chord. Chord means it cuts in 2 points, means equation 3 has what? Real and distinct. Now cuts the what? Circle in 2. Then equation 3 has real and distinct roots. Real and distinct roots, which implies that is delta greater than 0. Delta greater than 0. Delta greater than 0 means you can write 4 into, that is 1 plus m square into r square minus c square greater than 0, which implies 1 plus m square into r square is greater than c square. Therefore, hereafter, whenever the line cuts a circle in 2 points, then we have the condition 1 plus m square into r square is greater than what? C square. Greater than c square. Then I go for case 2. What is case 2? In case 2, when the line 1 touches the circle 2, then this is the figure. Now it touches at only one point, means A is equal to B, we call it as. So therefore, now this is a center. Then we can say that the roots of 3 are real and equal. Which implies delta is equal to 0. When the line touches a what? Circle, then the roots are real and equal. Therefore, delta is equal to what? 0. Delta is equal to 0 implies, now from the condition, what is delta? R square into 1 plus m square minus c square is equal to 0, which implies c square is equal to r square into 1 plus m square. This is the condition for the line to touch a circle at one point. So therefore, now case 3. What is case 3? Case 3 is when the line 1 neither touches nor intersects the circle. Then, so this is the concerned figure like this. This is the center. Then the roots of 3 are imaginary, which implies delta less than 0. We have what condition? Which implies r square into 1 plus m square minus c square less than 0. Therefore, r square into 1 plus m square is less than c square. Yes, we come across now the nature of the line and a circle. When the line cuts the what? Circle in 2 points, then it is a chord. And talking about the roots of the equation. The roots are real and distinct. Why? It cuts in 2 points. Therefore, delta greater than 0. We have the condition r square into 1 plus m square is greater than c square. When the line touches a what circle at only one point, then it is a tangent. So therefore, now A coincides with B. So therefore, now the roots are real and equal. Therefore, delta is equal to what? 0. Then, when the line 1 neither touches nor intersects a circle, then the roots of the 3 are what? Imaginary. We can say that the delta is less than 0. So therefore, the condition is, relevant condition is r square into 1 plus m square is less than what? C square. This is the standard method you can use for a line and a what? Any second degree equations to know their nature, whether they are cutting, they are touching, or what? Neither intersects nor touches the what? Circle, or any second degree. Even same concept you can use in what? Parabola, you can use in ellipse, you can use in what? Hyperbola. This is a common concept, comes in all the what? Chapters in the what? Second year coordinate geometry, that is circles, parabola, ellipse and hyperbola. Yes, we come across about when the line touches a circle, we have a condition c square is equal to r square into what? 1 plus m square. Okay, then I can take this as a note. When the line y is equal to mx plus c is a tangent to the circle x square plus y square is equal to r square, then the condition is c is equal to plus r minus r into 1 plus m square. We have proved just now by using delta is equal to 0. Now, when the line y is equal to mx plus c is a tangent to the circle, with c, it may be a tangent, it may not be a tangent. In place of c, if I substitute plus r minus r into square root of 1 plus m square, it is always a what? Tangent, or tangents also. So therefore, y is equal to mx plus r minus r into square root of 1 plus m square represents equation of tangents to the circle x square plus y square is equal to r square in slope form. So therefore, now look here. Now this is the standard equation of a circle. This condition, this represents, this equation represents an equation of tangents to the circle having the center 0, 0 and radius r. Then what about the equation of the tangents in a slope form for the circle having the center x1, y1? Let us see. Now, the equation of tangent to the circle x minus x1 whole square plus y minus y1 whole square is equal to r square. In the slope form, is y minus y1 is equal to m into x minus x1 plus r minus r into 1 plus m square. Plus r minus r into square root of 1 plus m square. Why? Earlier, for the what circle x square plus y square is equal to r square, what we have dealt in, it has a center 0, 0. Now its center is what? x1, y1. Yes? Now what I do is, look here, just by using the what translation of axis, by using the translation of axis, you call it as 1, you call it as 2. By the translation of axis, by the translation of axis, shift the origin to the point P of x1, y1, to the point x1, y1. Therefore, now small x is equal to capital X plus x1, small y is equal to capital Y plus y1, which implies this is with respect to small x and small y, this becomes capital X and capital Y. So therefore, capital X is equal to x minus x1, capital Y is equal to y minus y1. Now the transformed equation, new transformed equation or transformed equation of 1 and 2. So therefore 1 implies x square plus y square is equal to r square, you call it as 3. And what about 2 implies? 2 implies y, that is y is equal to capital Y is equal to m into capital X plus r minus r into 1 plus m square, you call it as 4. Now these two equations are in the standard form as we proved earlier. As what? When y is equal to mx plus c is a tangent to the what circle x square plus y square is equal to r square, we have proved the equation of a tangent in a slope form as y is equal to mx plus r minus r into square root of n plus m square. That was in terms of small x and y. This is in terms of what? Capital X and y. So therefore, what we understood from this concept is, when the circle is having a center x1, y1 and x1, y1 and radius r, then the equation of tangent to the circle in slope form can be written as y minus y1 is equal to m into x minus x1 plus r minus r into square root of 1 plus m square. This is with respect to the center x1, y1, and previous one what I told is with respect to the circle having a center 0, 0. Yes, now we understood the nature of the line and a circle. When the line cuts a circle in 2 points, delta greater than 0. When the line touches a circle, then delta is equal to 0. When the line neither touches nor intersects, delta less than 0. With that, we could come across the condition as what? R square into 1 plus m square minus c square greater than 0 is equal to 0 less than 0. So therefore, by is equal to 0, we could write as equation of tangent as y is equal to mx plus r minus r into square root of 1 plus m square. Right. Now let us find out, instead of y is equal to mx plus c, I take the line lx plus my plus n is equal to 0 is the line. Lx plus my plus n is equal to 0 is the line. When that line is a tangent to different circles, what is the respective condition and what is the point of contact? What is the point of contact? Okay. The next one is, you can call it as a note or a theorem. When the line Lx plus my plus n is equal to 0 touches the circle x square plus y square is equal to r square, then what is the condition and what is the point of contact? What is the point of contact? So therefore, Now I start. This is proof is. Now let P of x1 comma y1 be the point on the circle x square plus y square is equal to r square, at which the line Lx plus my plus n is equal to 0 touches. Okay, touches. So now when this line is touching a circle means certainly it must be a tangent. Therefore this is a point. This is P of x1 comma y1. We can call it as equation of a line. Now by definition we know that equation of tangent at P of x1 comma y1 to the circle is s is equal to x square y square minus r square is equal to 0 is s1 is equal to 0, which implies xx1 y1 minus r square is equal to 0. You call it as 3. By definition, this is a tangent at this point. He has given this line is touching a circle. Therefore, when the line is touching a circle, this is also a tangent. It means that equation 2 and 3 represents the same. So therefore, now since equations, what are the equations? Equation 2 comma 3 represents same. Therefore, by equating the coefficients, now look at coefficients of like terms, coefficients. Okay, so therefore now x1 by L, y1 by m is equal to, yes, minus r square by n. Now you cross multiply. This becomes now x1 by L is equal to minus r square by n, y1 by m is equal to minus r square by n. So therefore now I can write P of x1 comma y1 cross multiply minus lr square by n minus mr square by n. This is the point of contact when the line Lx plus my plus n is equal to 0 touches a circle x square plus y square is equal to r square at P of x1 comma y1. We could prove P of x1 comma y1 as minus lr square by n minus mr square by n. This is the point of contact of the tangent to the circle. This we call it as point of contact of tangent. Yes. Now look here. This point of contact lies on both the circle as well as the line. Now you take this point, you dump over in the line equation to get a condition. Yes. Now since P of x1 comma y1 lies on the circle x square plus y square is equal to r square, which implies x1 square plus y1 square is equal to r square. So now you substitute this point. So therefore that is L minus LR square by what? N whole square. Next minus MR square by N whole square is equal to R square. Now this becomes L square R power 4 plus m square r power 4 by n square is equal to r square. Take out r power 4 common factor. Now this is n square r square. Therefore 1 r square get cancels. We are left with r square into L square plus m square is equal to what? N square. Yes, we could prove when the line Lx plus my plus n is equal to 0 touches a circle, what's the condition? N square is equal to r square into L square plus m square. And when the line Lx plus my plus n is equal to 0 is a tangent, what's the point of contact? Minus Lr square by n minus mr square by n. Yes, now we understood when any line of the form Lx plus my plus n is equal to 0 touches a what circle, this is the condition. Instead of this, we can also prove by another method what I told. Whenever any line touches a what circle, I can write this one is r is equal to d. I told the what nature of the what lines. When the line cuts a circle in 2 points, r greater than d, touches a what circle, r is equal to d, neither touches nor intersects, I told r less than d. Instead of this, I can also write to prove this condition, I can also in another way, this is a center, the center is 0, 0, this is r, and we can call it as what? D. What is d? Perpendicular distance from the center to the line. So therefore, what is d? D is perpendicular distance from center C of 0, 0 to the line. What is the line? Lx plus my plus n. So therefore is equal to 0. Now I can write this equal to perpendicular distance. So therefore by definition I can write r is equal to d. What is r is equal to d? R is equal to d. Radius is r. Now this is equal to apply a perpendicular distance from the 0, 0 to this line. Ax1 plus by1 plus c by square root of a square plus b square. Ax1, that is L into 0, m into 0 plus n by square root of what? L square plus m square. Therefore r is equal to modulus of n by square root of what? L square plus m square. Squaring on both sides. Yes, now which implies I got it as r square into L square plus m square is equal to n square. This is the what? Required condition. What we proved here, the same condition we got it. This here we substitute that the what? The point x1 comma y1 on the circle, maybe in the line also, or else you can go by definition r is equal to d. R is equal to d, right? The length of the chord, to the circle having center, having the radius, radius r, and d be the perpendicular distance from the center of a circle to the chord. Now let us consider the figure. This is A, this is B, this is center. You take this is what? Radius. This is also what? Radius. This will be always a perpendicular bisector. Any line perpendicular to the chord, I told all of the basic properties of a circle. Any line passing through the center and it is perpendicular to the chord, it always passes through the midpoint. And D is the perpendicular distance from the center to the what? Chord or a line. And this length is what? Let it be x. Now how is that? From triangle ACM, it's a right angle triangle. I can write r square is equal to x square plus d square. So therefore, x square is equal to r square minus d square. Therefore, x is equal to square root of r square minus d square. Therefore, the length of the chord, since now length of the chord AB is equal to 2 times of AM is equal to 2 times of x is equal to 2 times of square root of r square minus d square. So therefore, hereafter, when r is the radius, d is the perpendicular distance from the center to the line, then the length of the chord to the circle is given by 2 into square root of r square minus d square. Right. Next, let us discuss about the position of the circle S is equal to 0 with respect to coordinate axis. First with respect to x-axis. Similarly, we can go for the position of a circle S is equal to 0 with respect to y-axis. Now I take, this is the figure, this is the x-axis, y-axis, let it cuts the circle, the x-axis, let the circle cuts the x-axis in 2 points. Let the circle S is equal to x square plus y square plus 2zx plus 2fy plus c is equal to 0 cuts x-axis in 2 points, A of x1 comma y1 and B of x2 comma y2. You call this as equation 1. 1 implies x1 square y1 square 2zx1 plus 2fy1 plus c is equal to 0. Okay, now x1, but here y1 is equal to 0. So therefore, I can write in place of y1 as what? 0. But as usual, I have taken this as what? x1 comma 0. In place of y1, we have to put what? 0. So therefore, now I will change this one as what? Wantedly 0. This will also become what? 0. So therefore, which implies x1 square plus 2zx1 plus c is equal to 0. You call it as c. Similarly, 1 implies, what implies? Now x2 y2 also x2 comma 0, that is y1 is equal to 0 here and y2 also equal to what? 0. So therefore, now 1 implies x2 square plus 2zx2 plus c is equal to 0, that is 0. Means here we have taken y1 is equal to 0, y2 is equal to 0. Why? These 2 points lie on the what? X-axis. Now from 2 and 3 you can very well observe, from 2 and 3 we can observe x1 comma 0, x2 comma 0 are the roots of the equation. What's the equation? X square plus 2zx plus c is equal to 0. You call this as a 4. So therefore, now this is a quadratic in what? X. So therefore, let its roots are what? x1 comma x2 I told. Therefore, sum of the roots x1 plus x2 is equal to minus 2z minus b by a. Next, x1 into x2 is equal to c. x1 and x2 is equal to c. So when you know the sum of the roots and what product of the roots, let us find out the length AB means what? Length of the chord on x-axis. Length of the chord on x-axis is nothing but x-intercept. The x-intercept made by the circle on x-axis. Similarly, intercept made by the circle on y-axis. So therefore, now on x-axis, AB is equal to, apply the distance formula, x2 minus x1 whole square plus 0. So therefore, now I can write this as modulus of x2 minus x1. So therefore, now AB is equal to x2 minus x1. I can write this one as, that is x1 plus x2 whole square minus 4 x1 into x2. So therefore, I can write AB is equal to x1 plus x2. We have taken as what? Minus 2z, right? Minus 2z whole square minus 4 into what? C. So therefore, now I can write here also 4. This becomes 4g, that is g square. That is 4g square minus 4c. So therefore, 2 into square root of g square minus c. So therefore, this is nothing but x-intercept, or else I can call it as x-intercept. And x-intercept made by the circle, s is equal to 0. Okay, s is equal to 0, or length of the chord. Now let us discuss whether it is a positive or whether it is equal to 0, whether it is what? Negative. We know already any quantity under the square root must be positive. So therefore, when g square minus c is greater than 0, when g square minus c is equal to 0, so therefore, when g square minus c is greater than 0, now roots are real and distinct. When g square minus c is equal to 0, then length of the chord becomes what? 0. Then the roots are what? Real and equal. It becomes what? Less than 0. It's a what? Imaginary. Means the circle neither touches nor intersects the what? X-axis. Intersects the x-axis.